Slowly but surely. Okay, I think we'll start now. The numbers are slowly still, and that's great to see. But hopefully with the introduction, we can get that information out of the way. And so by the time we get to the main event, which is you, Richard, we'll have the full complement of those who will be turning up. But for everyone else, thank you ever so much for joining us today. It's a very warm welcome from the UK Climate Resilience Programme team to this, our penultimate webinar in the series that has been going on for the entirety of the programme. So we're really excited that you're here joining us today, and that we'll get to hear a little bit about some of, or one of the projects which we've been privileged to be able to support. There we go. So just in terms of a scheduled timetable for this particular webinar, here we've got an introduction from myself. So I'm Pete Walton. I'm the Impact Translation Fellow as part of the UK Climate Resilience team here at the University of Leeds. And I've been given the great privilege of chairing this particular webinar today. I've got some news from the programme that I just wanted to highlight. All the information that I will be talking about is already on the website. So those of you that follow it, this will be familiar with you. If you haven't found the website yet, I suggest you do, because there's a lot of updates to the news which I'll be presenting today. Once I've had an opportunity just to let you know about some of the things that's going on in the programme, then we are very privileged to be able to hear from Professor Richard Chandler, ably assisted by two colleagues, Claire Barnes and Chris Brearley, who are on the call and just waving now if you can see them in the video chat. Richard's going to lead the presentation, and we have Claire and Chris who have been working alongside Richard on the project, who will be able to support with answering questions, etc., and picking up any points that may be appropriate for them to deal with. And the topic for today is a really exciting one, because it really reflects the diversity of the work that we've been able to do within the programme, insofar as recognising that diversity that we need in order to make the UK resilient. So we've heard from previous webinars on some approaches, maybe introducing storytelling as a way to engage, but we've also recognized that what we need to improve and develop are maybe some of the data sets that we have available to us to support that decision-making process. And Richard and his team have been working on the EuroCORDEX, as you can see from his title there, to expand the regional climate projections from the UK perspective. We're then going to hear from Carol McSweeney, who's from the Met Office, and I'll introduce Carol a little bit at the time. But it's exciting that we've got Carol along, because she's very closely, well, she's Deputy Science Lead for the UKCPA team project. And so her perspectives on how this supports the work that they've been doing is going to be really interesting to hear those reflections. What we're then going to be able to do is have some Q&A that the panel will be able to respond to, and then we'll look to end promptly at 1 o'clock. So just a few technical issues, some housekeeping as well. So as I mentioned, we're going to have the presentations. As the presentations are going on, what we would encourage you to do is to post your questions in the Q&A box. So where you've got the range of functions along on my computer, it's along the bottom, may well be along the top, you'll see a section that says Q&A. If you click on that, a window will appear. In there, you can pop your questions. But what you can also do is you can vote for your favorite questions. So if someone's posted something and you think, yeah, I'd really like to hear from that, give it a thumbs up. The more thumbs up, we'll prioritize those questions. If they're all roughly the same, then I'll pick my favorite ones, or what I think is going to be the most difficult for Richard to answer, just to put him on the spot. But if you have questions, please ask them. If we don't get through all of them, Richard's very kindly volunteered to address as many as possible after this particular event. We ask that you remain muted during this, unless we invite you to speak. Maybe there's a question which you've asked that we're not entirely sure about. Or the webinar is currently being recorded. It is being live streamed. The audio and the slides are going to be shared after the event. If you've got any technical problems, then that's where the chat function comes in. And I have a colleague from the climate resilience team who will be on hand to support you. And just a quick reminder that yes, the webinar is being recorded as we speak. So if there are things that you don't want necessarily captured, please don't put them in that public space. And of course, important reminder about some of the networks, the social networks, the Twitter, but you've also got the website that I mentioned in terms of finding out more information. So some quick announcements, some news, etc. So I mentioned when I hosted the webinar last time that the call for proposals for the ECHA conference, which is this year being held in Dublin, they've been announced, but just to let you know that the deadline is fast approaching for your proposals. It's on the 27th of February, so please be aware of that impending deadline. Also, just to highlight that the World Climate Research Programme, the WCRP, have that Open Science Conference. That's going to be later this year, between the 23rd and 27th of October. It is going to be online, but in face-to-face, it's going to be in Kigali in Rwanda. I've never been to one of their Open Science Conference, but I imagine if it's anything like the work that they've been doing, it'd be fascinating. Review and diversity of climate research, which is going on around the world. Again, the impending deadline for abstract submissions is on the 28th of February. So please be aware, if you did want to submit something, you don't have a great deal of time. Just to let you know that work within the programme continues apace in terms of the type of outputs. We are developing, colleagues are developing a number of papers which are being published. Here we can see ones from diversity of programs, looking at a range of approaches and understanding of both technical skills and also feasibility of certain approaches. So you can get access to those for free through our website. The final thing I want to mention is the final conference. Those of you that have been following the UK Climate Resilience Programme would have noticed that we did originally schedule this final conference, the celebration of the work that we've been doing in the course of the years that we've been in operation. They were going to be on the 1st and 2nd of March. We've now moved them because of strike action, as we mentioned, to the 8th and 9th of March. Day one is very much focusing on research advancements, and you can see the range of presentations and presenters there, and some of the panel session topics that we'll be covering. Day two is very much looking at it from the implications of practice and policy. And we're hoping that the DEFRA Secretary of State, Therese Kofi, will be joining us to give a headline address before we embark on a number of panel discussions. The event will be held at the Wellcome Collection. It will be live streamed, and my colleague will be putting in a link where you can register for the event. Now, you can attend in person, but just to note there that tickets are limited, but you can attend online, and you can register through the Eventbrite link that's been posted in the chat. What we do ask, because this is going to be a popular event, because there's going to be limited numbers, we do ask that if you do register as an in-person attendee, that you do excuse me, that you do attend, just so that it's fair on everybody else who might want to get a ticket but couldn't. So please be aware of that. Please follow the website for, excuse me, further updates. So that's a quick run through of the news since the last webinar. But now on to the main feature of this webinar today. And we're very pleased to have Professor Richard Chandler from the University College London here today to talk about one of the projects that he's working on through the UK Climate Resilience Programme on this issue of the EuroCORDEX-UK, expanding the set of regional climate projections for the UK. Now, Richard has extensive experience of developing and applying statistical methods for the environmental sciences, with particular interest including the analysis of time series and space-time data, with applications including areas of hydrology and the impacts of climate change. So I'm very much looking forward to hearing from you, Richard, in conjunction, where appropriate, from colleagues Claire and Chris from UCL as well. So I'll stop sharing my screen, Richard. Thank you very much indeed for taking the time out of your busy schedule. I shall hand over to you now.
Great, thank you very much indeed for the introduction, Pete, and thanks to everybody who's taken time out of their lunchtime to come and listen to this. So I'm going to share my own screen. Here we go. Hopefully people can see that. All right, so to start with, actually, Claire, give me a thumbs up if you can see my screen. Cool, thank you. So as Pete said, this is very much joint work with Claire, who you can see there, and with Chris Brierley. And actually, you know, I'm taking the credit for it by giving the talk, but Claire actually did most of the work. So what are we doing? We're talking here about a project that we've been doing for the last 2 years, really to supplement the regional component of the UK climate projections. So many of you will know about UKCP. There are several components, and we're focusing really here on the regional component, which is the 12-kilometre resolution, and is very widely used. One of the features of that component, though, is that it is based on a limited set of climate models. The projections there are based on a limited set of climate models, and therefore it may not sample the full range of possible futures that are conceivable. So what we've been doing over the last 2 years is to supplement that with other regional climate projections that are available, including the UK. The slide says that they are available to download from CEDA. That's not quite true at the moment, because I received a message yesterday to say they had started ingesting them. I don't know what the data will be like after that. I kind of imagine they'll come out the other end like a sort of soup, but they should be available by next week. And the key thing about that is that the information that we've put together is in identical format to the existing UKCP projections. Hopefully should be easy for people to use who are used to using the UKCP. So what I'm going to do today, I'll just start by summarising the additional data that has become available as a result of this project, and then I'll give a kind of a quick overview of some tools and resources that we've developed for different U groups, starting with people who might just be vaguely interested in getting an overview of what the different projections say, moving on to users who might want more detailed and more precise information later on. Okay, so first of all, what is the EuroCORDEX ensemble? Well, Cordex is an international initiative designed to compare many different climate models. And the map there is Europe, as defined by EuroCORDEX, and it's an ensemble of climate projections produced by multiple climate models. So many of you are probably aware that regional high resolution climate projections are typically produced by running global models at a global scale and then embedding the runs of a regional climate model within those global model runs. So EuroCORDEX has got unique global models at 10 regional models. Compared with the existing UKCP regional projections, which have basically 12 model runs that are all from variants of a single global model and a single region model. I should say that there are other components of UKCP 18 which do incorporate different climate models, and I think Carol's going to say something about that at the end. Of course, those of you who have tried to use climate model outputs will know that all climate models have their outputs on different grids, so they're not directly intercomparable, but all of the EuroCORDEX outputs are at a similar resolution to the UKCP regional projections. So what have we done? Well, what has Claire done? I mean, so we've cropped the EuroCORDEX outputs to the same spatial domain as is used in the UKCP regional projections, and you can see that on the maps there. It's been converted to exactly the same grid as the UK regional projections, using the same emissions scenario, etc. And there are 64 ensemble members, so you can see that in the grid plots here. So the columns represent different global models, and the rows represent different regional models. And you can see there are some gaps because some of the combinations of models have not been run together. Okay, so that's a background to the data. So let's just think about what we've done with them. So as I say, the raw data, or the processed data will be available for download alongside the UKCP 18 regional data. We have taken those data and computed a very, very large number of, if you like, pre-packaged analyses of those data so that people can look at biases, future projections, etc. And we've got basically evaluation runs that allow us to look at the historical performance of the models as well as projections available to 2080. As I say, we've produced a lot of pre-computed visualizations of the data, including maps of projections and biases, as well as distributions of overall quantities over the UK. And we've done that for the UKCP existing projections, the EuroCORDEX, as well as some of the driving global models. And you can see there's a web link at the bottom of the page. The QR code will take you to the same place. And I'd just like to demonstrate perhaps a few of the plots that you can find there. So I'm going to go to that web link. You might want to play along with this. So that web link will take you to this page, the home page for the project. And there's a quick links right there. And I'm just going to go to the EuroCORDEX-UK Explorer and open tab. So it's okay. So there's the first documentation at the top here. What I'm going to do, because Claire and Chris thought I should demonstrate this one, is I'm going to look at we can just new a whole load of different indices of climate. I'm going to look at heat wave stuff. So number of heat wave days, you can choose from the menu there. If you want to know how heat wave day size, there's an indices kind of QA there, which will say how all these indices are calculated. I'm going to produce just a look at the overall ensemble spread. I'll look at the 12-kilometre data. I'll go to some heat waves, probably rather than heat waves. And I'm just for the sake of illustration, I'm going to choose look at the change between 1981 to 2010 to 2050 to 2039. So I do that, we'll block the plot like this. Okay. And we can see, for example, that the UKCP regional and these are the project changes in number of heatwave days from the UKCP ensemble, from EuroCORDEX, and from the driving models there. So we see distributions of change, and we see that UKCP is projecting bigger changes in heatwave days in the future than EuroCORDEX, for example. That is generally fairly well known. One of the reasons is that the global model driving UKCP is known to have quite a high climate sensitivity, so it warms at a more rapidly than other thing. One way to try and a little bit is if instead of looking at fixed time periods, if we compare changes in different models corresponding to times at which they achieve specified thresholds of global warming. So, for example, we look at the ensemble at points where the global models get to 3 degrees of pre-industrial, we will get another plot. And zoom thing, I've got all the zoom windows open and I can see which plots are there. That's the initial 10. Okay, and you see we've pulled up here plot gains in 1 day on the period to the time at which models achieve global temperature increase 3 degrees. Okay, we see that brings the ensembles close together, but it doesn't fully represent.
Richard, I'm just going to interrupt there. Your sound is glitching, apparently. You've been requested to turn your video off. And hopefully that will sort it out. Obviously, we'll miss you.
Thank you. Yeah, okay, I'll try that. Got a message. Is that any better? Yeah, I have a message. I've got low system resources. I'm going to carry on, but let me know, Claire, if it gets any better or worse. So we can also look at maps to show the projection of the UK like that. Okay, and if you want, you can save the plots. If you click that button, you will get a zip archive with all those plots in it, and you can download the data that went into the plots as well. Okay, we'll leave that there for the moment. Claire, is the sound any better?
Yeah, it seems to not deal very well with you being on the website. So just talk slowly and we'll all complain very loudly if we can't hear you. I'll keep an eye on the chat and let you know.
All right, thank you. So obviously, I mean, everyone's got the QR code there, so you don't even have to listen to me now. You can just play on the website for the rest of the talk. Okay, so just as a summary of the comparisons there, so overall, the ensemble biases in the historical period are generally fairly small. The UKCP regional projections are fairly similar to the coarser resolution global projections, but projected future changes are typically smaller for the EuroCORDEX ensemble. Now, so that gives an overview of the of the kind of plots that are there, and you can go and play in the Plot Explorer to your heart's content. There's tons of stuff to explore there. But of course, we've got all this amount of extra information now, and there's a bit of a question of information overload, maybe. You know, you kind of think, what do you do with it? And in particular, if you are wanting to use some of these climate projections, for example, to run impact models or something like that, probably you're not going to use all 64 members of that EuroCORDEX ensemble, and you might want to know how to choose, if you like, representative members particular application. So we've done a little bit, well, we've done quite a lot of work actually to try and produce tools that enable you to do that. And essentially what we're doing is finding out where the interesting variation is in these big ensembles of projections by using dimension reduction techniques to give an approximate representation of the ensemble structure. And the technique, so this is a new technique called ensemble principal pattern analysis, and we call them EPs. So essentially the idea is that we're going to characterize those maps that you get out of the different ensembles in terms of dominant spatial patterns, and each ensemble member will have a score associated with each pattern, and we can look at the scores to see which, if you like, are the most extreme members and which are the most representative, etc. So just to give you a flavor of how this tool works, here we've got 12 maps of the UK showing changes in percentages of wet summer days from each of the 12 members of the UKCP 18 regional ensemble. They're all red, suggesting that in the future the percentage of wet summer days will decrease. Red is for drying when it's precipitation. Okay, and you can see that some of the ensemble members are more red than others, so some project a greater degree of drying than others. In the context of the EPPs, the ensemble principal patterns, the map on the left here shows the mean of all of those 12 maps that I just showed you on the previous slide. The first ensemble principal pattern accounts for 81% of the variation in the ensemble. So basically, each ensemble, the maps on the previous slide can be approximated by adding multiple this map to ensemble mean.
Sorry, Richard, you're breaking up a bit again. Can you turn your camera off? Sorry. It might help.
Right. Thank you. You'll just have to look at the puffin instead. All right. So yes. So each of the 12 maps on the previous slide can be approximated by taking the ensemble mean and adding multiple of this pattern to it. So, for example, ensemble number 13, you'd multiply this pattern by minus 0.5, add it to that, you'll get the result. Okay, so with the first two ensemble principal patterns here, and apart from using the dimensions, because basically we're capturing the 12 maps that we had before, we're now just two or three maps. We're able now to do a plot like this, which shows the scores of each ensemble member according to these patterns. You see, for example, ensemble member 8 is a bit of an outlier, so there's something interesting going on with that particular ensemble member. If you wanted to choose just 2 or 3 ensemble members to drive your impacts model, well, the extreme ones are perhaps numbers 13, which has the lowest score on the first principal pattern, and either 4 or 12, which have the highest score. So they're the most, they capture the range of variation in the ensemble to some extent. This is Claire's way of doing mathematics with maps that shows how we can use the ensemble principal patterns to reconstruct individual members of the ensemble with high accuracy. For the EuroCORDEX ensemble, it's a little bit more complicated because, of course, we've got some members share the same global model and some members share the same regional model. And you can see on the little array of plots up there, there's a vertical line of red maps there because there's one global model that is much warmer than the others. So we've extended that the ensemble principal pattern approach to account for this ensemble structure, and we do separate analyses to understand what variation is coming from the global models and what variation is coming from the regional models. And again, the Plot Explorer contains examples of these EPP analyses. I'm not going to go through those now because of time constraints and because my computer doesn't seem to like it when I'm on the web page. But if you want, you can explore those ensemble principal patterns on the Plot Explorer. The final thing I'd like to talk about is ensemble post-processing, because basically what I've discussed so far has been really aimed at summarizing the information that is there. But as we've seen, different ensembles, UKCP and EuroCORDEX, produce different projections. So if you want to use this information, you might say, well, how do you reconcile those differences? If you are doing planning and decision support for future mitigation, for example, you might be worried about how reliable the information is, and what about biases in the climate models? How can we ensure that the climate models are telling us something about the real climate system rather than just about the model world? So we've done some work now looking at post-processing the projections in order to try and answer these questions. And in doing that, we've sort of gone a bit back to basics, really, in statistical terms, because I think everybody has done a Stats 101 course where you start off being told that when you sample from a population, you have to ensure that your sample is representative of the population, and everybody says, yeah, that's really obvious, and then completely forgets about it in their subsequent science work. So in the current context, the sample, the data available, is the ensemble members and the historical observations. And what we're interested in doing is making statements about the future of the real climate. So how does the sample here relate to the population? Well, there are some critical features that we need to recognize, which is that the ensemble members come from climate models, and models look more like each other than they do to the real climate system. So we can expect that there will be shared discrepancies between the ensemble members and the real climates. And of course, the EuroCORDEX ensemble is even more complicated than that, because different ensemble members share the same global model, different ensemble members share the same regional model, etc. So we've developed a post-processing framework based on statistical representations of the structures that we see in the ensembles. And given the time, I'm not going to go through this in too much detail, but it is based on a paper of mine almost 10 years ago now, and other authors have picked up this kind of framework as well and are working with it. I'm going to show you some. Let's leave the mathematical details a little bit. Basically, we've applied this framework to yearly time series of temperature and precipitation. And what we're doing is we're saying I'm going to have to put my camera on because I feel a need to wave hands around here. We're saying that each of the projections has a trend. The trend is related to the forcing, the emissions scenario that was used to drive the models, and we're using that information to post-process the ensemble outputs. Claire, how's the sound with the video? We're okay at the moment. All right. So here are some examples of the results here. So we've done this for temperature and precipitation annual time series and seasonal time series.
It's less good. Yeah. If you're done waving your hands, I'd turn your camera off again. Sorry.
Okay, are we better? annual and seasonal time series. And we've got a few visualizations that are available from the project webpage. Look like the plots here. Some of them look like these plots here, where you can see in red, here is the historical observed temperatures. The orange scribbles are the individual ensemble members, and the band going through the middle there is the uncertainty band. And what we find is that this process actually does reconcile most of the inter-ensemble differences. And so I'm going to be a little bit brave, and I'm going to try and show you this on the website. And I'll let Claire pick me up if that does work. So what I'm going to do, I'll shut down the Plot Explorer page, just in case that helps. So there's another link on the main page here, which says visualizations of regional temperature and precipitation series. So that link will take you here. Claire, how are we doing for sound? I'll try and speak real slow then.
Yeah, I was going to say, if you just, we're kind of losing every third word, so slowly is good.
All right. I think, okay,
also, we're
slowly is
close
good.
to time, I'm being told.
Time. So the only thing I'd like to show you then is these plots, which show samples from the future uncertainty distributions, and these are designed to show what the future might actually look like. So each of these animated time series is, if you like, an equally likely version of the future. And I think that's quite helpful in communicating the uncertainty in the future. Okay, so I think this slide summarizes very briefly what I've tried to cover in the presentation. I'm sorry that the sound quality was not as good as it could be. There are various other things that we have produced in the project which are listed there. There are some reports on the web page that give you that information. And as Pete said at the beginning, I'll be very happy to answer questions either live now or via email later on. Thank you all very much indeed for your attention. And as I say, I'm sorry about the audio problems.
Richard, thank you ever so much. And there is absolutely no need to apologise. I mean, with all these situations, we can only rely on the IT that we're presented with. So I really appreciate you pushing on through. And I also appreciate Claire helping out with the technical issues. That's really appreciated. As Richard mentioned, if you do have any questions, maybe there's a point of clarification where maybe the sound broke up a little bit, and you want to just clarify what it was that Richard was referring to, then you have the opportunity to do so in the Q&A. There's some questions being populated already, so thank you for those participants who have put those questions in there. If you like those questions and you want to vote for them, then please do so. But if you want to put your own in there as well, then we would invite you to do so. In the meantime, we have the privilege of welcoming Carol McSweeney from the Met Office, who I had introduced earlier as the Deputy UKCP Science Lead for the Met Office, who is working on assessing simulations of regional climate change and guiding their application in climate change impact studies. So there is no person better qualified to respond to the presentation. No pressure, Carol, to Richard's presentation. So I really appreciate you taking the time, Carol. And also I know that you're having your own IT issues. So if are you still requiring me to take or to drive the presentation?
Yes,
for
please.
You? Okay,
yeah,
let me share the screen. So hopefully, Carol, can you see your presentation?
Yeah, that's great. Thanks, Pete.
Okay, just let me know as you want to advance. We've got about sort of 5 minutes or so to work through your response.
Great. Okay, thank you. So I'll try and meet your high expectations from that introduction. I'll keep my video on for now, but if Claire was happy to offer her useful interruption service, please do shout if you're having any problems hearing me. So thanks for that really interesting presentation about some really useful work that I think really does complement and support what we're doing with UKCP. What I want to bring in the next 5 minutes or so is just a view from the perspective of UKCP on where those gaps are in the information that we're currently able to offer. What are some of the immediate opportunities and developments that will help to address that, and then maybe I'll dangle a few interesting kind of research and development directions at the end, where we think maybe there'll be useful things to think about going forward. So next slide, please, Pete. So where are we now in terms of what we're offering through UKCP? We've heard already from Richard about the dynamically downscaled products in UKCP. We offer these at 12-kilometre regional climate and a 2.2-kilometre local data set, so that is convection permitting and is particularly useful for understanding extreme rainfall. But it's true that those two products both currently only include variants of our own Met Office model. And that has a number of implications around capturing the spread in future scenarios. So in this figure on the right, these come from Glenn Harris in the Met Office, and Glenn has compiled what some of our different UKCP products say about future summer temperature, precipitation, winter temperature and precipitation. So in the box plots, we have our probabilistic estimates. So these bring in a much wider range of uncertainty information. So not only our own models, but also CMET5, also additional uncertainty information around carbon cycle uncertainties. The global products from UKCP currently include a subset of 13 well-performing CMIP5 models. So they're the blue dots, as well as our own global members, which are the orange dots. And then, of course, we've got our downscaled products at 12 and 2.2 kilometres. So where we are with those products is that the 12-member ensembles in local and regional products do sample only the higher end of the responses, particularly in summer temperature. They sample the drier end of summer rainfall projections. And similarly, but to a lesser extent, they sample the warmer and the wetter end of the range for mean winter climate. So that's something that we know about the ensemble. We do advise our users to combine information across these different strands in order to provide some of the wider uncertainty context for those higher resolution products. But it's true, I think, to say that in practice, that is difficult to do, particularly in a quantitative way. And often that information comes in perhaps through early conversations about a piece of work or a product, or through bringing in caveats and limitations at the end. So if you could just flip to the next slide, please, Pete. When we look across some of the really exciting and interesting applications of UKCP, those particular examples here actually happen to all be through UKCR projects. That wasn't deliberate, but we tend to see those applications focusing on the 12 members. Examples that bring in other information are harder to find. I've got one example in the bottom right-hand corner there that came from Laura Dawkins in the Met Office, where she's brought in some EuroCORDEX members to try and explore the sensitivity to including that uncertainty in her assessment of the risk of lost physical work days with excessive heat. But I think it's fair to say that we have a gap in that information, and also a gap in the other methods that people might use to combine information sources, and those kinds of workflows that people could look to address that situation. So next slide, please, Pete. So we do have these upcoming developments that will help to address this. One of those, of course, is this data set designed through UKCR to support what we offer through UKCP. We also have a new set of regional and local models in progress at the Met Office. So they will be driven by 4 CMIP5 global models offering 12 and 2.2 kilometre information. And I think these 2 different strands of information really help to fill these gaps that we've already got, but they also offer 2 quite different philosophies. On the one hand, the UKCP approach, bringing in CMIP5, taps into the earlier methodology that we use to select CMIP5 members to go into our global ensemble, and that was based on assessing how realistic the large-scale regional characteristics are, and how well they sample from the range of future outcomes. And the idea being to offer a smaller set of selected but well-performing members based on our physical understanding. And I think what can be offered through the UCL's contribution through EuroCORDEX is something that is complementary to that. It brings the offer of more models and tools and quite a lot more flexibility for users to select particular members that meet their own needs. They can do that using a larger number of indices, draw in information about how closely those members map onto observations. And it also offers the opportunity to bring in information from multiple RCP scenarios. So there's two different kind of strands of information there, offering different utility for different user preferences. The challenge, I think, for us in UKCP is to think about what guidance we offer to our users about how to use both of those different threads, and perhaps to offer example workflows. So we'll be going to our user groups and asking what kinds of questions they might be asking about how to use this information. Next slide, please. So finally, I promised to dangle some interesting kind of future avenues. This is by no means exhaustive, but there are some of the things that we're thinking about in terms of underpinning science and next capabilities. So I think there are 2 different ways we can maybe approach this issue about, let's call them gaps in uncertainty space, which I think will always be an issue, particularly around UK sort of convection permitting simulations, which is, because of their resource intensiveness, is hard to offer for a large ensemble. So there are, other than running more of them, there are other solutions about filling that space. I do think that we would like to see some more examples of quantitative methods for combining information from perhaps coarser models with some of these high resolution products. There's work out there currently looking at other approaches, things like statistical emulators, machine learning. How can we use indicators to estimate what might be the properties of downscaled models? We haven't been able to downscale yet, and I've got an example there from a nice paper that Stephen Chan in the Met Office and Newcastle University wrote on large-scale predictors of extreme hourly rainfall events that we can only get at otherwise through those very high resolution CPM projections. And also there's a component of CPM uncertainty that is largely unexplored certainly in UKCP at the moment. And finally, just the second kind of way of looking at these alternatives. Thanks, Pete, for going on to the second slide. I think there are other things to learn in the way that we look at these simulations. We've been involved in a project in the last few years called EuCP, and that's done a lot of work to look at observational constraints and the impact on projection uncertainty. And I think that we can bring in some of that learning into selecting members for use in specific impact assessment. And there we really see, we've compared in the EUCP a range of different uncertainty quantification methods and tested their skill. And we find that for temperature-based metrics, there's a real demonstrable benefit to constraining with observations. And we don't yet see that for rainfall. So there's a challenge there in how we resolve the multivariate issues around applying constraints. I think it's important to not forget the decision context in here. Some of those parts of uncertainty space may not always be important for some studies. And I think that's as we open up these cascades of uncertainty, bringing in more and more of those different components, we broaden uncertainty. Actually, they're coming at things from the other way. We can ask which parts are we most interested in. And finally, Richard did also refer to looking under global warming framework. This figure on the right is a figure that Jason Lowe produced, actually using data he generated using the UCL EuroCORDEX tool. And we can see that some of that uncertainty is clearly linked to the rate at which models reach warming levels. But at the same time, we do need to be wary and keep in mind some of the challenges and perhaps unexplored angles around using global warming levels in terms of the timing of changes. So that was a bit of a rattle through there. I hope it gives a little bit of context around how we see that work fitting in the UKCP context. I'm just going to take the opportunity to put a plug in now. Within UKCP, we have kicked off recently a user survey, which is part of a longer term user engagement to help us shape future projects. So if you are a user of UKCP or interested in using those products, please do hop over. You can find that link on the UKCP news website, and I will try to drop the link into the chat. So yes, please do participate. Thanks very much.
Stop sharing that screen. Carol, thank you ever so much for that response. And there was a lot of detail in terms of how the two are aligned. It's really valuable for our participants to hear that. And my apologies for if I was advancing slides too quickly. I was trying to multitask and doing it very badly. In terms of trying to see some of the other questions that were coming in. So please accept my apologies, and also apologies to the participants as well. But I really appreciate you both, Richard and Carol, giving such detailed presentations. Now, we do have time for some very quick questions. Just looking, I can see that Richard, can you see the Q&A window? I can see that Emma's question has got three thumbs up. So Emma is asking, this is all interesting, probably great for academics, but how do you foresee us having the information for adaptation plans at an organizational level? The user aspect has been referred to quite a bit, but clearly Emma feels that there's an opportunity for us to really consider, maybe in a bit more detail, about how users can support their decision making at the organizational level for adaptation. So Richard, can I invite you first to respond to that question, and then maybe if Claire and Chris and Carol, you have thoughts as well, then we can chip in there as well, but I'm mindful of time.
Okay, thanks, and thanks for the question. I mean, I guess to some extent it depends what organizations need. So for some of the adaptation plans, all you might need is an overview of what the projections are saying, so that you've got that in the back of your mind. And I think the Plot Explorer would provide a very useful way of accessing that information. The indices that are on there were actually produced in consultation with the UKCP user group with Fai Feng at the Met Office helped us with that. So we got user input into what we actually produced. We have got some examples of things that people have done with the data. Chris, did you you had some involvement with that, didn't you?
Yes, I did. I don't think we've done an awful lot with it yet, is the simple answer. I mean, I think we're still at the working out what people need and what people want. I've been off chatting with my local council to do it, and I've run a lot of MSc projects looking at various aspects of this data set. But yeah, I still think we're at the position of having created the data set and done what we can with the data, rather than being directed enough to focus particularly on problems.
I think I would just add to that, possibly on Carol's behalf, that if anyone does have anything in particular they need, you've just been given a link to how you can tell us what you need us to tell you in order to support that kind of adaptation planning. So yeah, join the user group, tell us what you need. Or tell Carol what you need.
Yeah, so I think that might be my cue to come in there, and I think that is a big question posed, and there are quite a lot of different answers in terms of what we do in the wider UKCP framework. So UKCP provides information to a number of different kinds of users. Some of those are in governmental departments, some of them are in larger organisations that deal with kind of infrastructure type decisions. We work quite closely with our user group to co-develop what we call co-develop UKCP. So we take input around the kinds of questions that those users are trying to ask and try to use that to shape these products. I would say there's a number of other sort of steps in the process between the information that we provide and that decision-making context. So one thing we do is provide information that is used to develop climate services. We provide information that feeds into the National Climate Change Risk Assessment, and that also feeds into some of those decisions. I'll stop there so that we can get on to another question.
Yeah, no, Carol, thank you ever so much indeed, and thank you to the other panelists in terms of responding to that question. We are bang on 1 o'clock, and such is the time that it's flown by. And there are plenty of other questions that have been posed. So thank you very much for sharing those questions, and also for sharing links to other resources, etc., that have been going on in the chat. Now, they have been captured, obviously. We mentioned that this has been recorded, so we'll be able to share those, so you'll have access to those recordings. What I just wanted to do is just one final plug, because such is the opportunities, as Carol and colleagues have taken the opportunity to do, and that is to just let you know that the next webinar that the UK Climate Resilience Programme in the series will be offering is by a colleague, Nigel Arnell at the University of Reading. We'll be looking at the high impact scenarios for the United Kingdom. Nigel, as it happens, did the very first webinar, and it seems almost appropriate that he would bookend for the very final one. What I would like to do in these last few moments is just to thank all our panelists for their time in developing the presentations, for their commitment in terms of the project over the course of the programme. So thank you for that. And also for overcoming the difficulties with IT that might have scuppered most mere mortals. So thank you very much indeed for your contributions. And thank you for those participants and the attendees who have come along today. I hope that you found it rewarding and interesting, and you've learned that little bit more about some of the work that the UK Climate Resilience Programme have been able to support. Thank you very much indeed to everybody. Any remaining questions, colleagues from UCL have very kindly offered to try to respond to them. So we'll make sure that those responses will be available as well. So thank you very much indeed. I wish everyone a lovely weekend when it arrives, and thank you very much indeed for joining us. But for now, goodbye.